testing. You hear me okay out there? Okay, all right. Everyone, it is good to see you. Welcome back from your spring break. You're probably chomping at the bit to get back into Unity, back into XR development. And I think I've said this before, but there's this very famous phrase that distance makes the heart grow fonder. I talked about this in 494 a little bit earlier today, but taking breaks and getting proper rest, especially on topics that you enjoy, very, very important for avoiding something called burnout. Burnout, right? When you engage with a topic so intensely and for so long that the topic starts to become very, very fatiguing, right? So if you work on making a game or making a VR or AR app for 8 hours straight, you may find yourself not really wanting to work on it when you wake up the following morning. Taking breaks, okay, taking a break from development, like a big week-long spring break, is usually a very healthy way to keep your passion alive. Keep it burning and not burn out. So when you engage on some sort of project or some sort of long-term effort, make sure you plan some breaks in as well. And if you find yourself working hard and late into the night because you're just engrossed in your work, you're in that flow state, I would encourage you to consider setting it aside. Set it aside. You will wake up the following morning with more ideas, with rest, and you'll be hungry to get back into it. Whereas if you just go through the entire night, you may find yourself burnt out and you won't touch the topic again for a few months. So be very, very careful. In game dev, in XR development, burnout is a very common and very serious problem, and you don't want it to affect you. It will hammer your productivity if you let it get to you, okay? Okay, so look at where we are. We just had this nice long spring break. We are still in the middle of our P2 Alpha assignment. P2 Alpha is kind of a tricky assignment. You've got a bunch of tasks you need to knock down, I think maybe getting back into it, you'll need a little bit of a refresher. Today, we're going to show you how to do some additional things in Unity. We're going to show you how to do the acorns. We're going to show you how to instantiate a new game object, give it a velocity, and then detect a collision with some other object, which is what you'll need to do for some of your tasks on P2 Alpha to finish that up. In particular, you will need to be able to, in the AR mode, launch an acorn, send it flying toward your cursor, and then have it hit a squirrel. And the squirrel will flee once it gets that acorn, okay? And so we're going to show you how to do that today. I'm going to start loading up our Unity project so we don't burn too much time. If we have some extra time at the end, we will start talking about some of the inner workings of augmented reality. And so hopefully you'll get a little bit of a better feel for how modern AR technologies actually kind of work under the hood. So you can kind of look forward to that. We also are kind of closing in on the end of our Culture 3 assignment, our film assignment. The film ended up being Ready Player One, a very famous, very large-scale, big-budget Hollywood blockbuster film. So you can enjoy watching that. It's a pretty pleasant experience, I think, a little bit long. Our next film, Culture 4, is going to be a much harder film. Much shorter film, one that is a little bit disturbing and one that is a little bit harder to fully appreciate. And so that is a film, Culture 4, that I strongly recommend you watch with the group if you can, okay? So we're going to finish up P2 Alpha, then we're going to finish up P2 Gold, and then we'll be on to that final project, okay? You are only about 7 weeks away from graduation. That's it. 7 weeks, not that long. And so hang in there and do the best you can. I've got a company that I want to show you. This is a company, an XR product that's a little bit unique. You might not think of it as an XR product, but it is indeed all about altering your reality and your perception of it. And this is a company, a product I used a lot when I was at Meta in Seattle. I was running a lot at the time, and so I used an application called Zombie Run. That is called an audio-only XR startup for fitness. It is actually a game, so we can take a look at it here. ZRX, transform your workout into adventure. Zombies Run is an application. Let's see if we can find it. Here it is on the Google Play Store. If you look at the application, it doesn't show you a lot of what looks like gameplay. That's because this is an application, kind of like a Runkeeper, that you mainly put in your pocket when you're out on a run. You're out on a jog, you're walking through town, you're on some sort of aerobic workout. And what happens here is that they are going to tell you a story in your ear. It's kind of like an audio novel. But at certain moments in the story will require you to do certain things. In this case, there are moments when you will get chased by zombies and you will have to run for a certain amount of time to get those zombies off your back. And they will augment your perception of the world around you by making it sound like the zombies are getting closer to you or fading into the distance if you're running fast enough and stuff like that. So let's see if I can find a video for you. At one point, they had a really nice video. Let me see if I can find the trailer, maybe. I should have just linked it right on the document. All right, let's see here. YouTube. So let's go Zombie Run app. Okay, here we go. Zombie Run 2 launch trailer. Okay, 12 years old at this point. My goodness. Well, at least they're still around and kicking. 1.2 million views. Not too bad, huh? Let's take a look. Hello?
We had a zombie attack last night. Low on everything. We need whatever you can find to get going.
Collected a bottle of water, a radio and a box of batteries. 2.4 kilometers, 17 minutes.
Right on your tail. Don't look back. Zombies attacked a nearby farmhouse. The survivors are on the roof. We can't just leave them there to die. Something's going on in those labs. We need you to investigate. What you find could save lives. In the zombie plague, you have to go in alone.
5 kilometers, 29 minutes. Zombies detected.
He's positive. Run, bye. You lost him. Come on home, Runner 5. We're one step closer to saving the world.
So you can see the basic gameplay here is trying to get you to do what's called an interval workout, which is where you're going to have a certain segment of the story where you are encouraged to walk or jog and recover. You're going to be provided some context for what you're doing during that workout. And then from moment to moment, you'll be given this more intense scenario where you need to start running. And it will keep you running quickly for a while, and then it will peel the zombies back and give you that rest interval. So very, very common way to train track and cross country. I did it a ton when I was in those two sports in high school. and it works extremely well. You can see that there's a lot of gamification kind of happening in this app as well. So they're trying to give you context for why you are doing what you're doing, why you're running, where you're going. You've collected an item. If you run long enough, you'll use those items to build some sort of base and enjoy the game after you've collected those items. It's all an effort to get you using the app and using the app in a way that hopefully will make you healthier. And so that's the premise, okay? I think this is a free application. They don't make money by you just downloading the app itself. But I think they do have kind of in-game microtransactions and stuff like that. And I think you can purchase additional portions of the story if you want to. You only get kind of like an intro, like a prologue bit of the story if you don't pay anything. So, yep, kind of interesting. And social impact, obviously, pretty great. Get people out there, get people working out. Anything we can do to get people outside and moving is going to be a good thing. They are based in London, as you might have expected, via the accent of the voice actor there. And yeah, a kind of an interesting way to do XR, because with XR, we're usually thinking about how to affect your visual perception and not so much audio. But sometimes you can do interesting XR by just targeting the audio-only route. So now you have a good example of this. Okay. Later on in this course, we're going to talk about business and XR and business and game dev. And it's a really interesting talk. Companies do some unintuitive things sometimes, but once you understand the way that big institutions work, you can predict them in many cases. So a question is, why do our big companies care so much about the latest tech trends? Why did Meta go all in on XR? Why why are they now in every company? Why is Microsoft currently going hard in the paint on AI? Even as AI starts to show some signs of kind of hitting its limits. And one big reason is that everyone has heard the story of the RIM BlackBerry, okay? Has anyone heard of BlackBerry? Research in Motion? Okay, BlackBerry is famous. It was famous for being kind of a early smartphone that was very focused on security. And so it was a very common phone that business leaders and municipal leaders would have. I think Obama famously had a BlackBerry, and he also famously switched to iPhone. The creators, the CEO of BlackBerry was also very famous, and we talk about this in EECS 298, for saying that the iPhone wasn't going to be a big deal. It wasn't an issue, all right? We don't really care. We're not worried about the iPhone. Microsoft, similarly, was very late to the smartphone revolution. They completely missed it. They came in late with Windows Phone, and they had a lot of very cringy way of doing this. I want you to watch this. This is something they did. This was a fake funeral procession that they ran when the Windows Phone was coming out. And it was a funeral procession for the iPhone because it was dead. We're going to finish it off with the Windows Phone. Take a look at this. So where is the Windows Phone these days? Anyone know? You probably haven't thought about Windows Phone in a while, have you? Yeah, it didn't work. It didn't go so well. Microsoft sometimes feels like an extraordinarily well-resourced team of people who don't quite know what's going on. But everyone knows that Microsoft completely failed to see the smartphone revolution coming. And Intel completely failed to see it coming. That is why smartphones all use ARM chips instead of Intel chips. And of course, RIM, Research in Motion, failed to see it coming too. Every CEO, every tech leader knows this story, and they are very, very intent on not being left out in the cold. So whenever there's any sort of new tech hype wave coming in, whether it is XR or whether it's crypto or generative AI or metaverse or whatever, every company is going to immediately throw resources at that problem. Why? Because if you burn a lot of money on crypto and Web3, no one's really going to remember that you did this. As long as you don't burn too much money. You can burn a lot of money, just don't burn too much. But if it blows up, well, you'll be in good position to not be late to that party. And so it is just the best odds for the leadership to throw money at any new big thing. So keep that in mind. Companies right now are, especially tech companies, are very sensitive and very, very vulnerable to this idea of missing the next big tech hype wave, to the point where they will overindulge in any upcoming tech wave, regardless of its merits. And then years later, you'll find out whether that tech wave really mattered or not. Okay? There's a new HBO documentary out. It's called We Met in Virtual Reality. And it was kind of a big thing, especially during the pandemic, that there were all these online communities forming in places like the metaverse, in VR chat, and to a limited extent in Meta's Horizon Worlds. And a lot of these relationships that formed in the metaverse turned out to be surprisingly legitimate and genuine. It's not a huge group these days, but it is a group. It does exist. And so I want to show you the trailer for this documentary really quickly. Let's take a look.
Making friends here is sometimes what saves people's lives. Or gets them up out of bed in the morning. I am a teacher for Helping Hands, a sign language community here in VR chat, and Western Elder, and we're going to go like this. Christmas.
Slow. Quick. Slow. If I had confidence that I could teach hands as a living in VR, I totally would do exactly that.
With a long-distance relationship, having VR is a game changer. We are 5,000 miles apart, but we're gonna try our best to make it work.
This year has been really hard. The thing that has been missing has been VR and the VR community. I would not have weathered this without you guys.
You can be who you've always wanted to be, and you can, in a way, start over.
We can come together and support each other. This community means a lot to me, and I really want them to know that they're loved.
It's been years since I've seen Kevin's IRL body.
Okay, so I want to point out a couple things about this trailer. VR chat, which is what you're seeing here, actually succeeded in a way that Meta's Horizon Worlds, which is kind of a VR chat clone, did not. And, by succeeded, I mean it has, I think, upwards of 50,000 players at any given time. That's not enough for Meta to be happy. Meta wants the entire population of Earth in their metaverse at all times. But VR chat has nevertheless defeated Meta and has carved out a nice little group of players, a nice niche that it serves very, very well. Something I want to point out in this screenshot right here is that we're looking at this screenshot, and at least, I think, 2 of these characters are copyright infringing. Okay, we have Gizmo right here from Gremlins. I'm sure VR chat does not have the rights to use that character. And I'll also point out that in this trailer, and I'm just watching it, these avatars are thirsty, okay? Like, these are not the kind of avatars that if I were holding my class in VR that I would want to be seeing in my classroom, okay? And that is, I think, something that Meta and big corporations miss. It's a humongous weakness of institutions. Okay? The fact is, if you want to get a bunch of humans together, humans they're nitty, they're gritty, they do things that we would say are spicy or thirsty. They do things that are not advertiser friendly all the time. That is what makes a place feel human, okay? The breaking of rules. And that is not something that Meta can abide, okay? If you look at Horizon Worlds compared to VR chat, let me see here. You will have this very kind of, I think, uncanny feeling of sterility. When you look at Horizon Worlds, when you look at any big corporate product, it feels so safe, so corporate, so sterile and clean. It feels very soulless. That's another word that's been used a lot lately. And it's just going to be really hard for big teams and big companies to own the future of media when what it seems like most humans actually want in media is a certain grit to it, okay, a certain authenticity. That often means non-advertiser friendly stuff. So anyway, that's something I would ask you to keep in mind, all right? Okay, did you know that you can actually simulate augmented reality mode within the Unity editor itself? I didn't realize this was possible until recently, but Piazza, from a previous semester, you can actually go to Edit Project Settings, XR Plugin Management, and then you can go to this Monitor tab and you can enable XR Simulation. And if you enable that, when you go to the AR mode in your project, I think it will work a little bit differently than just showing you that basic black screen. All right? So it could make testing your AR mode a little bit easier because you might not need to build and deploy to your mobile device in order to test that. Okay, you should be able to just go and do your testing in the editor, which could be really, really nice. Okay, and then just a reminder, Culture 3 has been released. I actually want to show you one more thing before we get into our main topic for the day, which is getting into the Unity editor and developing that acorn throwing mechanic. I want to show you some changes I recently made to the A2 game engine. A2engine.org is a website where we host the A2, the Ann Arbor game engine. And this is actually the game engine that we make as students in the EECS 404 Game Engine Architecture Upper Level CS course. This engine is it's become surprisingly usable. It is a C++ engine programmed by us at the University of Michigan from scratch. It is a multi-language piece of software. In the course, you actually learn how to put Lua, a Lua scripting layer, on top of your C++ code base, high-performance C++ code base, and it's very featureful, actually. You are currently learning Unity. Well, the A2 engine is very much a 2D version of Unity without the editor. So you still have ways of creating components, of adding physics. You can create fairly advanced games. Here's one that I'll show you right here. This sample game, is called Physics Obstacle Course. And when you launch it, you can see that we've got our game engine executable right here. And we can launch that executable, and I'm running through the game, and I am jumping, and we got this nice physics going on. We got our rigid body component going on. We've got custom mechanics like these bounce pads. We've got UI and the timer. We've got collision detection. Okay, when I collide with this finish flag up here, we will stop the game and we will take note of our score. There we go, finish, total time 26 seconds. All of this is in a completely custom game engine, and all of this can be found in this resources folder. Every game is actually entirely within that resources folder, which is run right next to your engine. You can find all the different component types In our engine, we write our components in terms of Lua. In Unity, we write all of our different component types, our component classes, in the C# programming language. Then you can take these components and you can put them onto actors by going into our scene file. The scene file, which in Unity is called the .unity file, is just an array of actors. And each of these actors is a JSON object, and we can specify what the name of the game object is, and we can specify all the components that the game object has. This one has the camera manager component, this one has the game manager component, the HUD component. And so you can really get some very advanced results out of this game engine. Here's probably my most advanced one. It's got cutscenes, it's got transitions, it's got all sorts of fun stuff. And I'll just run it really quickly. Okay, here we go. And yep, so here we go. We got audio. We've got audio. We've got a kind of a custom mouse cursor. We got all this stuff. We've got some pre-staged cutscenes. We've got slide-based cutscenes. I can walk around. We've got enemy AI. We've got pathfinding. We got all sorts of stuff in this game. We've got stealth, right? So a pretty involved game, right? They'll even chase you if you get in their way. They'll knock you out, right? Lots of stuff. Anyway, this game is just meant to show you that within a few months, you can create your own fully featured game engine, and that game engines themselves are a topic you can study from the ground up, not just in the sense of I'm going to learn a game engine to make an XR app or a game, but I'm going to learn game engines to make my own engine that has my own unique features, or maybe an engine that is very good for a particular kind of game, okay? That is what... Yeah, that's what I want you to realize, okay? Game engines themselves are a unique discipline that you can study in isolation if you want to. And if you really want to, you can take the Game Engine Architecture course, which is offered every winter semester. So, a bit less than a year from now, okay? So, what I want to do is I feel a little bit messed up right now. So what I want to do is I want to take our 5-minute break now. I'll step outside, and then when we come back, we are going to do some programming. Okay, we're going to program in Unity. I'm going to show you how to do some of the Acorn-related tasks, and we're going to start from where we ended up in our last recording, our last lecture. Okay, so I will see you in about 5 minutes. Okay, see you then. Okay. Okay, all right, back to it. So let's take a quick look at where we ended up last time. The last few lectures, we've been doing a lot of development in Unity. We've been tackling some of the tasks that you're going to need to face for P2 Alpha. Let's take a quick look at what those tasks are. Just a quick reminder. Let's look at that task spreadsheet. Here it is. So you've gone through and you were able to do a lot of the P1 milestone tasks, but we have a lot of these tasks. Let me see, P2 Alpha, the red ones. So you've got tasks that relate to trees, different types of trees that you must kind of spawn in, and they need to grow, they need to do things. You have a bit of UI at the top of your screen that needs to keep track of some numbers, some data, right? How much currency do you have? We already went through and we added some of this kind of stuff. We added these seeds to the bottom of our UI, and we even made it scrollable so you can go between the seeds and look at how much of each particular one you have. We even made it so that when you click, it will consume a seed, and it will update the number, and you can run some code if you want to when any of these buttons are clicked. So I'll go ahead and do that after Mapbox finishes loading in. I click on the acorn, and then I can keep clicking, and I'm running all of this code. You can see the messages happening. So that's all really, really good. So we've got the UI figured out. We did the landmark technology as well. Remember that little house that we have anchored at Notai, at the Notai coordinates? You will need to go in and make your own seed shop. That means doing a little bit more UI. My tip for the seed shop is to create some more UI elements. Go into your canvas, and you can create, for instance, a panel in here and start adding buttons and adding text to the panel. We can go ahead and make that panel kind of tinier if we want to. Let's go to the scene. Double-click panel, we can kind of see it a bit better, right? So as I slide and change these numbers around, move right over here, I can kind of shape it and get it the dimensions I want. I can anchor it and bring it down from the top a little if I want to. You can add all of your seed panel stuff to the shop, and then when you want the seed panel, the shop panel to appear, you can simply enable it or disable it. Enable it or disable it. This is actually in the C# code. It's the active self status. So you would use a function called setActive to click this checkbox, to uncheck it or fill it back in. And that's a pretty easy way to build the UI you want for your seed shop and then make it appear or make it disappear. Okay, so we already kind of showed you how to do that. The orbit camera is kind of a tough task. But you can read this hint document right here. It will remind you of some of the trigonometry concepts that might be very useful to you when it comes to allowing people to kind of rotate that camera when they click and drag parts of the screen. The compass is quite an easy one, but there is a hint document here. You can make the compass work in about one line of code if you do it correctly. The acorn is one that we are going to do in class. And we're going to do a partial walkthrough of the squirrel as well in class. And I think that's what we're going to do today. You already know how to do music from our previous demonstrations. And this image tracking currency boost, we have a video you can watch on YouTube that will kind of help you get a feel for how to do that. So we have the question of a squirrel. Okay, we need to create a squirrel. Now, we should actually probably go and find a squirrel. Let's go find a squirrel on Sketchfab. This is, good practice for importing models into your Unity project. This is kind of like EECS 298, a big topic in EECS 298. Just this question of, well, you found something really great online, but when you bring it into your engine, it looks terrible. Why does it look terrible, and how can we fix it up? That is a big topic in 298. I'm going to check this little downloadable box. We're going to find a nice squirrel, okay? I don't want a pricey squirrel, so I wish I could have a little. I wish I could have a little free checkbox as well. But let's see if we can find a squirrel. Okay, here's a squirrel. All right, I'm going to download it. See what formats I can get it in. I don't see any good formats here. No formats that Unity really likes. Now, we could still use this squirrel, but we would need to bring it into Blender and re-export it as some other format. So I don't want to go through that effort. I'm going to look for a different squirrel, okay? I think we've used this one in the past in a lecture, but I want to try and use this one right here, okay? This squirrel does not have a bushy tail. This looks more like a rat to me, I'll be honest. Maybe I don't want to use it. I don't know. Let me see here. Let's find a really nice squirrel. Can we find any decent squirrel in here? Come on. Low poly squirrel. That's kind of cool. Oh, this is another great low poly squirrel, but it's paid. All these paid squirrels. This does not look like a low poly squirrel to me. This looks crazy. What's that?
It's just like polys.
Yeah, I mean, it just looks like a bunch of geometry. Oh, here we go. This is, I think, a good low poly squirrel. Let's see what format it comes in. It comes in the .blend format. That is good enough, okay? We generally, for Unity, we need a .blend, we need a .fbx, or we need a .obj. Those are the three formats that I'm fairly certain work reasonably well. Let's extract this zip folder and open it up. Go into source, and we have this .blend file. Looks good to me, but we don't really need this folder, so I'm going to cut Control X, and I'm going to bring this Sketchfab file outside of here, this blend file. And now I can just drag that low poly squirrel folder, the whole folder. I can just drag it right into my models folder in my project pane. So we're going to open that up. Let's find our models folder. There it is. And I'm just going to drag in that squirrel just like this. Low poly squirrel. There we go. Okay, give Unity some time to process that .blend file coming in. What Unity is actually doing is it is detecting the fact that this is a .blend file, and it is using Blender, the Blender version installed on your machine, to process that model and get it ready for the engine. So now that we have our model, I want to kind of go back. Let's go back to our little tree here down here. We want it to be roughly the size of this house. So I'm going to drag my model in. And if you look at it, it has a few problems. So this is just a classic 298 situation. This model comes in with a light, which we don't want it to have. Okay, and it comes in with a camera, which we don't want it to have. So I'm going to open up this little folder here, this little game object. Remember, in Unity, you often have game objects that have child game objects, and those child game objects have their own child game objects. So in this case, this squirrel has a bunch of game objects underneath it. One of those is a camera. I'm going to find that camera in the hierarchy, click on it, I'm going to turn it off. I'm going to go to the light source, and I'm going to turn it off as well, and now our squirrel actually looks kind of reasonable. Okay? But you notice that when I, actually, you know what? This doesn't look half bad. This doesn't look half bad. And so what I'm going to do now, what I'm going to do is I'm going to grab this squirrel, now that we've kind of fixed it up. I'm going to actually change its name. I'm going to call this the squirrel prefab. And I'm going to drag it into the project pane. When I do that, we now have two files. We have the blend file that we initially brought in, and we have the squirrel prefab.prefab file. I can delete this now, and I can bring in as many of these squirrels as I want. I can spawn them with my C# code. I can do whatever I want. And one of the first things I want to do, actually, is I want to come in here, and I want to make my prefab larger. Because, a squirrel in real life should probably be smaller than the house. But for our purposes, we want this squirrel to be easier to hit, so I'm going to actually make it about the size of the house. So let's go back to our blend file. I'm going to, over here, click on Model, and I'm going to switch the scale factor to like 5, and I'll click Apply in the corner. And we're going to see how this looks. There we go. That's looking a lot better, all right? And this is going to be much more visible when we go to actually play our game with that zoomed out camera. Now this squirrel, we already know, is going to need to be able to move around. And you're going to have to write that part so that the squirrel in AR mode is kind of moving around and you can shoot it with the acorn. So how do we move things in Unity? Well, you can write a component to move things. That would work. Another thing you can try is you can try giving it the rigid body component. And this rigid body component is a very powerful one. It's going to give a sense of physics and collision to our game object. So we probably want to turn off the use gravity here because we don't want the squirrel falling downward and through our floor. And I'm going to give it a collider. I need a collider component, and I'm going to choose a box collider. As soon as I add this box collider, you can zoom in and you can see, wow, this box collider is extremely small and it doesn't fit our squirrel very well. So we need to resize this box collider. I'm going to go to the box collider, and if you open the box collider up, you can see that it has this size on the x-axis, and I can just click on it and drag that to make it about what I want. I can make it larger on the y-axis, and I can make it larger on the z-axis. If you look, though, it's kind of off-center. We want our collider to be a little bit ajar. So I'm going to go to the center property. I'm going to raise this box up just like that. So it fits most of the squirrel, reasonably snugly. Okay. So now, if we go and throw an acorn at the squirrel, we're probably going to see that, hey, it is actually hitting that collider. Good. Okay. Sweet. So, this is another big principle of game engines and game dev. The way that an object looks in the game, the way that a character looks in the game is often very, very different from how it collides in the game. In other words, the physics and collision volume that compose a character is often very different and much less precise than the way a character is rendered, the way the character looks. So the way something looks is often very different than the way that it collides with the world. Why? That's because collisions are very expensive. Collisions are more expensive than rendering, typically. And so you want to use simpler geometry when you go to process and detect collisions than when you are rendering the character. Okay, so anyway, we now have this character, the squirrel prefab. Now we've changed the squirrel prefab right here, the game object, the instance of the prefab. You know what? I don't want this to get confused. So you know what I'm going to do? I'm going to change the name of the squirrel prefab just back to squirrel. I'm going to delete the prefab right here. Delete it. This squirrel now has lost its prefab, so I'm going to drag it back in to recreate that prefab. Now, we know that this is the prefab down here because it says squirrel.prefab. That's the name of the file. Up here, we just see a squirrel, so it's an instance of that prefab. And we know it's an instance of a prefab because it's got this blue text here. I added a bunch of features to this squirrel, and the prefab now has these features as well. The prefab has the rigid body, it has the box collider. If I didn't do that, I would have to go up to the overrides here, and I would have to click apply to push my improvements, the box collider, the rigid body, from the instance into that prefab for the squirrel. It's a very common bug that you have an instance of a prefab and you make a bunch of improvements to it, but then the prefab doesn't have those improvements until you go to overrides and click apply. And so it's a very common bug that you spawn in a bunch of additional squirrels and they lack the components that you thought it was going to have. So we have this squirrel here, and let's actually run around in the game just to make sure that we can see it all right. It's not too small. Okay, so we're going to run the game we're going to let Mapbox load. You can see my cursor just going in and out, in and out, in and out, right? Okay. Come on. Here we go. And I want to find that squirrel. Where is that squirrel at? Where could it be? Hello? It is, it's to the north of us. So let's go north a little bit. And we're going to go find that squirrel. There it is. The squirrel is super easy to see. I think it's a great size. Now, what we need to do is we need to be able to shoot an acorn at this squirrel. Something to note is that shooting an acorn at the squirrel is something we only do in the AR mode, i.e., in the interaction scene. So we are currently in the exploration scene, which you know by just looking at the top of the screen or the top of the hierarchy. But we really only want to be shooting these acorns and fighting the squirrel in the interaction scene, i.e., the scene that has our AR cursor, the scene that we basically built way back in tutorial AR. And so we are building the squirrel in this scene just for testing purposes. You would need to go and actually change this and fix this up and move this to the interaction scene in your project. So make sure you understand that. Okay, when I tap the little acorn button, I want to consume an acorn and I want to actually send an acorn flying. But one thing to ask is, where do we want to send it flying from? We have this main camera, which is kind of angled downward. And when we tap the acorn button in our inventory, we want to run some code that spawns in an acorn object, acorn game object. That means that we should go make an acorn prefab because we want to spawn a lot of acorns, as many as the player has. And so we need to have a prefab. That means we should probably have a good acorn model. So let's go find an acorn model on Sketchfab. Find one that is downloadable. Ideally, one that is not too big. So let's look at this one. Low poly acorn. And we got ourselves an FBX file. And so we can just kind of grab it right here. I'm going to open it up. We're going to get it ready like we did with the previous one. Okay. Let's extract all. Go into source. And we have our acorn.fbx. I'm going to name this folder low poly acorn. And then I'm just going to drag this folder right in to the bottom of our project pane. Let's see here. There it is. Let's go to our models folder, and then I'll drag that folder for the acorn right in. Okay, there we go. And now we need to size it correctly, so I'll go down near the squirrel. We want the acorn to be kind of a little bit smaller than the squirrel. I'm going to drag it out. That acorn looks a little bit too small to me. So I'm going to go into our little settings here, click on the model, the .fbx file in our project pane. I'm going to go to the scale factor again under our little model tab. I change it to 2, click apply, and now we got this big, nice acorn. I think I'm done. I'm going to rename it simply to acorn, and then I'm going to make ourselves a prefab by dragging this object into the project pane. Now I can drag it out and make as many acorns I want. And if I want to change something, like make the acorns twice as tall, I can change all the acorns by just changing the prefab. But I actually don't want to do that, so I'll set it back to 1. Okay, so this acorn, we already know a few things about it. So this acorn is going to have to move. We are throwing this acorn at the squirrel. We're throwing it right out of the camera's direction. And so it's going to have to move, but it also has to detect collision. It must detect collisions with the squirrel. And so it has to have 2 components that we care about. One, rigid body. And I can turn off gravity again because we're going to give it motion. We don't really need to throw it and see it arc, okay? So I'm going to turn off the gravity for the acorn. And then I'm going to give it a collider. So the acorn has kind of a spherical shape. If you look at it, a box collider would definitely work, but there are other types of colliders too, and one of those is a sphere collider. There it is. And the sphere collider is way down here. That's totally not what we want. So I'm going to move it into the center of the acorn, and I'm going to make its radius larger so that it kind of fully encompasses the whole acorn object just like that. Look at that. It looks very nice. Now, if you look, this acorn, acorn 2, has these nice new components on it. But if I go to acorn 1, it doesn't have them. They are both using the same prefab, right? So I added these components to my acorn 2 game object, but the prefab doesn't have them. So I need to propagate these changes to the prefab, which means I'm going to click on acorn 2. I'm going to go to the overrides button at the top of the inspector. I'm going to click apply all, and look at this. Now when I go to the other acorn, it has those components. Why does it have them? Because the prefab has them. I click on the prefab down here in my project pane, and now the prefab has those components. Don't forget to do that, all right? Okay, so the acorn should have everything it needs to move and to bump into that squirrel. But we still need some code that's going to launch that acorn. We got to spawn in an acorn, and we have to launch it out of the camera and give it that direction that's going to head toward the squirrel. Then, when it touches the squirrel, we need to detect that so we can destroy the squirrel and the acorn. Okay? So, what do? Well, what I want to do is I want to go find that acorn button. If you remember, we have inside of our inventory at the bottom of the screen, we have this scroll view. And if we go deeper into it, we have this first inventory button that has our acorn icon on it. And it's even been set up with this inventory button component that is called acorn. So this, to me, seems like a great place to put some acorn logic. Okay? So when we tap that acorn button, we need to spawn in our new acorn. We need to take that new acorn and use its rigid body component to give it a velocity. Okay, so not too tough. Let's go find that spawn acorn button. Where is that function? Here we go. Here's our function. It's called spawn acorn. And this is the code that's going to run when we click on that acorn button. Okay? So we need to call a function to instantiate a prefab. And the function we're going to call is called GameObject.instantiate. And if you open the parentheses, it needs a GameObject reference to the prefab that we want to instantiate. Unity needs to be told, okay, you want to instantiate, you want to create a GameObject. Which one do you want to create? And so we have to have a way to provide that information. So a very common way to do this is to create a new public variable, public GameObject, and I'm going to call this acorn prefab. And this acorn prefab is what we're going to use to actually create our new acorn. We need to provide this function with some additional information. We have to give it a position to spawn at. So what position should we spawn at? We should spawn at the main camera's position. Okay? The main camera is this game object right here. There are many ways we could get the position of the main camera. But one really easy way to do it is to go and use camera.main. This will give us the camera component of whatever the current main camera is. i.e., if you look at the camera we have right now, main camera, we're going to get this component by doing camera.main. Then we can get the transform component right here by doing .transform, and that is going to give us the position we want right here. We're going to spawn in our acorn at that position of the main camera. Now we have to also tell it what angle should the new object have, what rotation should it have. And if you don't care, you just give it quaternion.identity. This is kind of the default rotation. And that's it, okay? This function, gameObject.instantiate, is going to give us a reference to that new acorn. So I'm going to create a little variable. I'm going to call it new acorn. And so then we can do things with it as we go along. Now, I want to test this to make sure it's working. And actually, it's not going to work. Can you tell me why? We created this variable for our acorn prefab. But just because we created a variable doesn't mean there's anything in the variable. All variables begin as null unless you do something with them. So we're going to go to that inventory button as soon as my Unity stops freaking out. We're going to go to inventory button. We're going to go to that component, and we can see our new variable is right there. The public GameObject acorn prefab variable is sitting right here, and I can drag in that acorn prefab, or I can make it a bit easier. I can click this button, I get this little menu, and I can just search for acorn prefab. I have to click on the Assets tab to get what I want. But there we go. That is acorn.prefab. And so I'm going to double-click that. And now, let's test this. I'm going to run the game, and I'm going to click the acorn button a few times, and we're going to, see if the acorn spawns. Okay. There we go. I'm going to run around a little bit. Now, watch this. Watch this very carefully, okay? I'm going to bring my scene view down here so we can actually watch what is happening with the main camera when we play. Here's my main camera, and I'm going to start walking around, okay? Do you see? I'm walking around. Now, I'm going to press my little acorn button, okay? I'm going to press my acorn button. Ready? 3, 2, 1, boom! I pressed the acorn button, but nothing happened, okay? And I'm going to press the acorn button again, boom! And look at this. These little shadows are appearing. And if you look in the scene view, you can figure out what's happening. We are spawning acorns. We're spawning them at the camera's location. But one thing we are not doing is we're not moving them. So they're just kind of hanging here above our camera. That's why we can see the shadows of the acorn below us, but we don't see the actual acorn itself. It's just not moving, okay? So there's more logic that we need to have. So we're spawning in this acorn, but we need the acorn to move. Now, in order to move the acorn, we're going to use the acorn's rigid body component. Let's go into our little acorn folder. Here's the acorn prefab. I'll double click it for you so you can see it. And I'll bring my scene view back up here. This acorn has a rigid body on it, which will give it velocity and acceleration and all that good stuff. But we need to get that rigid body on the acorn in order to do something with it, in order to give it the velocity it needs to have. So we have this acorn game object, and if we want to get this rigid body, then we have to call that famous .getComponent function. And remember, you specify which kind of component you want to get via these little carets. It's basically a templated function. And we're going to specify, I want the rigid body component. And then this is going to return me a rigid body reference. So I'll create a little variable. I'm going to call it RB, okay? And now we have that rigid body. We have this exact rigid body on the acorn. We now have it inside of our RB variable. So if I type RB and then press dot, I have all these wonderful options. There's even the gravity option that we saw earlier and we turned off. But that's not quite what I want. What I want is something relating to velocity. And as I begin to type .vel, I can see there's this velocity vector. Vector 3, XYZ, okay? So I can set this velocity vector to anything that I want. So I could set this velocity vector to just take the acorn straight down. That is something that we should actually try. So X Y, Z. And Y is up and down, so we actually want this Y to be something like negative, how about negative 4? We'll see how fast the acorn moves, okay, with that negative 4. So let's return to Unity, and we're going to let this code compile. It's currently compiling, which is why my Unity editor is not opening up right away. Okay, here we go. And we're going to run our game. I'm going to leave the prefab view. We're going to run our game. We're going to spawn some more acorns and see what happens, okay? So here we go. Here we go. Okay, and all right, ready? I'm going to spawn this acorn. Boom, there we go. And look at that. The acorn is going down. Now, this isn't quite what we want because our acorn is spawning on our camera and it's just kind of going down here. We really want the acorn to go out from the camera. As in, if I press the shooting button, I want the acorn to head toward my character. This is basically where the reticle would be if we were in the AR cursor, where it would be if we were in interaction mode. Okay, so this isn't quite what we want. We also want this acorn to go faster because this is super, super slow, okay? So how can we get the vector 3? We need a vector 3. How can we get the vector 3 that is coming out of our main camera? Well, if you look at this main camera object, you can see that the frustum of the main camera is pointing down at this kind of down left angle. Now, if you press the X key, you can switch from global coordinate to local, and then back again if you keep hitting X. You can tell what coordinate system you're in based on what you see up here in the scene view. But if we switch to local, we can see that this blue vector called the forward vector, this local forward vector, is coming out of our object, out of our camera in exactly the direction that we want. So we need to be able to get this blue forward vector. And if you're curious, this red vector is called the local right vector, since it's always sticking out the right side of the object. And this green vector is called the local up vector. And so we want to get this transform blue local vector, okay, the forward vector. And we can easily do that, actually. We're going to take this new acorn, we're going to get its transform, and then we can type dot forward, okay? Hold on, dot forward. There we go, dot forward. And this dot forward vector, which is stored inside the transform component of our acorn game, of our main camera game object, is going to be this blue vector right here. So that's exactly what we want. And so we can multiply this forward vector, probably not by 4 because that was super slow. How about something like 20? Let's really pump it up. Let's move quite a bit faster, okay? Around a little bit more than 4 times as fast as previously. So let's come in here and let it finish compiling. Mapbox does a lot of strange things to the game, like how it compiles and how it runs. It has to like load everything at the beginning of play. It's a little bit funky, but still gives us a lot of great technology though. Okay, so I'm going to run along and I'm going to press that acorn button. Ready? 3, 2, 1. Okay, and oh my goodness, what happened? Did you see what happened? In order to debug this, we bring the scene view down here. We didn't end the game, okay? We're going to go to the main camera, and I'm going to watch what happens when I press that acorn button. Ready? 3, 2, 1, click. Look at that. The acorn is totally going the wrong way, okay? That thing is going the wrong way for sure. So what happened? What did I mess up? Here's what I messed up. I am grabbing the acorn's forward vector instead of what we actually want. The vector I'm grabbing, if I click on the acorn here, I'm grabbing this blue vector off the acorn, when what I really want is the main camera's blue vector. right here, the forward vector. So I got the right vector, I just am using the wrong game object. Okay, I'm getting it from the wrong source, the wrong game object. So instead, what I'm going to do is I'm going to do the same thing I did up here to get the main camera's position. I'm going to do camera.main.transform to get not the position, but the forward vector of that main camera. Okay? And I'm going to go ahead and let's end the game and let's reboot it. And we'll see what happens now. This is why you want to be testing all the time so that you can figure out what these problems are and you can resolve them very, very quickly. I had a Red Bull as EECS 494 was starting about 4 hours ago, and I think it's wearing off, all right? All that sugar, the sugar high has led to a sugar crash. Okay, here we go. Ready? 3, 2, 1, and there it goes. And the acorn is headed straight toward my character. It even bumps into my character. I can even kind of move it around. What we really want to test is, will the acorn hit the squirrel? So let's do it. Here it goes. I just aimed it at the squirrel, and it's coming down. It's going to hit the squirrel, and boom! It hits the squirrel and knocks it away. But that's not actually entirely what we want. It's cool that it hit the squirrel, but if you go to the scene view, you can see that like the acorn and the squirrel are still here. They're just kind of moving through space, okay? We want to despawn the acorn and the squirrel. And within the game's logic, I think you might even want to give the player some money, or you might want to run some code that allows the trees to start growing again. So we need to do something a little bit more. All right, let's do this. I want to come in to this acorn. And what I'm going to do is I'm going to add a component to my acorn prefab. I'm going to call this defeat squirrel on touch. A very descriptive component. This component is going to detect when my acorn has touched the squirrel. And if it does touch the squirrel, it's going to despawn the squirrel and it's going to despawn the acorn too. So thinking about this, I should probably have multiple squirrels so I can do higher quality testing. So I'm going to go to my squirrel and I'm actually going to create another one right here. That's fine. Okay, my acorn prefab, all of my acorns will now have this defeat squirrel on touch component. But the component itself won't do anything, all right? It is empty. If we double click it, we can see there's nothing in here. We just have 2 lifecycle functions, and we don't actually need either of them. We do need this lifecycle function. It's a very special one. It is on collision enter, okay? And when we have a function that is very specifically called on collision enter with a capital O, C, and E, and when it has this parameter, collision, okay, this is going to run, this function is going to run whenever our game object bumps into anything. So that's really cool, right? The problem, though, well, I'll let you know what the problem is in just a second. Let's say this. When I bump into something, how do I know what I bumped into? Well, Unity will give us this little collision object, this collision parameter that comes in. This is Unity's way of telling us what is the thing that we bumped into. It gives us additional information so we can program interesting, unique game mechanics. The game engine has to give us that info. If I want to know what game object I bumped into, I can go collision.gameObject. And then if I want to get rid of it, I can do this. I can do destroy. I want you to destroy that object that we just bumped into. Then I want you to destroy ourselves, okay? I want you to destroy the game object that we are on right now. So that should make the squirrel disappear. That should also make the acorn disappear as well, okay? So let's go ahead and run the game. Here we go. Let's run the game and let's see what happens, all right? I'm going to walk over here. I'm going to walk over here to these squirrels, and I'm going to launch an acorn at them. We should expect to see the squirrel despawn, and we should expect to see the acorn despawn as well. So I'm right on top of the squirrel, ready, launching the acorn. There the acorn goes, and there we go. The acorn touched the squirrel, and it disappeared. Now I'm going to do something a little bit strange. I'm going to launch the acorn at my player. Here goes the acorn, and I failed to move out of the way, and my player just lost its head. My player's head just despawned. Okay, that is not what we wanted, all right? If you look at our logic here, our logic is not very advanced. It has a big problem. Currently, if we bump into anything, we destroy that thing, and then we destroy ourselves. So the acorn is like a wrecking ball. Anything that it touches, it is going to destroy. And so we can go and we can add some additional logic to make this more nuanced. We want to check if the thing that we bumped into is a squirrel. Now, how can we do this? How do we know if a game object is a squirrel? Because many game objects have a rigid body, and many of them have a box collider. We could check the name by doing this. If collision.gameObject.name is equal to squirrel. But there's a problem with this approach. This squirrel has exactly that name, but when we spawn in additional squirrels, they will have a different name. They'll have that 1, 2, 3, 4. They'll have the number after it, so it won't work. What we need to do is we need to go to our squirrel, and we need another way to annotate the fact that this game object, this prefab, is a squirrel. And this is a really, really good use case for the tagging system. If you look at any game object, they all have this little tag up under its name. And if I go to the prefab also has this tag under its name. I can go in and I can create a new tag. I click on Add Tag, and now I can go Squirrel. Okay, we now have a squirrel tag. If I go back to our squirrel prefab, I can go and make it not untagged, but I can give it a tag. I can give it that squirrel tag. Now, all of my squirrels will have that squirrel tag. As you can see, our two squirrels both have it. And I can actually check that tag to see if it's the squirrel tag or not. I'm going to put my logic into this if statement, so we will only do this logic if our acorn touches an actual squirrel, okay? So let's test it. I am going to send an acorn flying at my player character game object. I'm not going to move out of the way, and we're going to see what happens, all right? Hopefully, my character will get to keep their head. I think they will. Okay, here we go. Ready? 3, 2, 1, launch that acorn. Boom, it just kind of bounces off and goes flying on its way. Perfect. I still have my head. But now we're going to launch this acorn at the squirrel. Okay, ready? And I missed the squirrel. Okay, we have to restart. Bummer. Maybe I should make the squirrel or the acorn's hitbox a little bit bigger, its collider a little bit bigger, to make it less likely that I will miss. Okay? All right, ready? Ready? Here we go. 3, 2, 1, launch. And I've got a second acorn just in case I miss again. And boom, just like that. All right? So we now have a custom collision that occurs only between the squirrel and the acorn. And this is pretty much exactly the logic you're going to want in your AR interaction scene. There are some additional things you'll want to do. You'll want to figure out how to make the squirrel move, because the squirrel is required to move around and, take some evasive maneuvers. And that really just means the squirrel is kind of making itself harder to hit by walking around, okay? But note, you will need squirrels on the exploration scene to show that a squirrel is currently attacking a tree. And then you'll need a different type of squirrel game object, maybe a different squirrel prefab, for the actual squirrel combat in the interaction scene. So you might have 2 squirrel prefabs, okay? One for the exploration scene, one for the interaction scene, doing slightly different things, all right? And that, I think, is all I want to show you for today. Does anyone have any questions on any of this squirrel and acorn business? Okay, sweet, very, very good. So let's leave it there. When we launch Gold, when we launch the Gold assignment on Wednesday, we will probably have one final Unity workshop that we will do together. I will show you how animations work in Unity because you need to have your player character actually walk and animate when you are moving. And so that's not very hard to do, and we will do it probably on Wednesday, okay? All right, cool. So we have a bit of extra time. So what I want to do, is I want to talk to you a little bit about some of the inner workings of augmented reality. Augmented reality has a lot of crossover with the field of computer vision. And as computer vision improves, our ability to understand the actual world, the world around us, improves greatly as well. So let's go ahead and take a look at the inner workings of augmented reality. Understanding the space we're in is a very, very big deal. If we just see this as an image, as a bunch of image data, then we can't really do anything within this world. We can't really understand where the light sources are in this world. If we can't understand where the walls are, where the edges are, if we can't take this 2D image and create a 3D mesh from it, then we're in big trouble, okay? Very big trouble. So my objectives with this lecture is I want to talk to you a little bit about the different types of augmented reality that are out there today. I want to give you a little bit of a taste of how augmented reality works and is implemented under the hood. And this is a very big topic. Computer vision is an entire course, an entire field of research dedicated to improving at this. We'll talk about things like spatial mapping. We'll talk about object detection, body tracking. Occlusion is a very, very big problem we've already seen when it comes to AR. We'll talk a little bit about GPS because I consider that augmented reality. And so when you want to augment your reality, well, you have a couple problems that you're going to face. When you look at this image, it looks very appealing. The footage is very impressive. Of course, it was fake. Okay, it was completely fake. Magic Leap is a company that scared up a lot of investor money because they basically kind of lied that they could do this. Okay, they showed this footage of their product without telling people that it wasn't from their product. It was just a completely fake little aspirational concept video of what they were trying to achieve in AR. But this GIF is very informative for us as well because it kind of gives us a strong feel for why is this appealing? Why does this look like it fits? Why does it look like it's real to us? So the brain, right, and I think I actually got this particular image backwards, but the brain typically senses things via electronic signals coming in through your eyes, but also through your ears and through your sense of touch and smell and taste, okay? One problem that we have to figure out is how do we add the sensation that there's a whale in this room, okay, in this gymnasium? How do we convince people it's there? Well, one solution is to go actually find a whale and lug it over there and then just throw it onto the gym floor, which sounds very expensive, very time-consuming, and also very cruel. That whale would probably not find that very pleasant. But it would give you a very realistic sense that there's a whale in front of you because there actually is a whale in front of you, okay? This is expensive and cruel, not a good solution, okay? What we need to do is we can't change reality, but we can change your interpretation of that reality, okay? In other words, make them think there's a rail. If you think back to The Matrix, which we watched during our first cultural assignment, there is no spoon, right? That entire film is dedicated to trying to get Neo, the main character, to realize that the things that threaten him in the Matrix don't exist. Thus, he has to choose to believe he's been shot. He chooses to believe there is a spoon there. In reality, he needs to realize the truth. There is no spoon, and thus he can make it bend if he wants to perceive it as bending. Okay? Basically, this is the Matrix. We want to hijack and we want to manipulate, and when I say those two words, it sounds kind of evil that we're doing this, doesn't it? We want to manipulate your perceptions, your senses. Neural implants are quite far off. Otherwise, we would just do what the Matrix does, which is just kind of percolate and prompt your electrical signals in your brain, your neurons, to believe whatever we want you to believe. Okay? There are other ways to manipulate your senses. Okay? This is $3,500 augmented reality with the Vision Pro. Or there are very strange mushrooms out there which you could probably buy for $20 to augment your reality. And I've never done that, but I've heard it can be quite a trip. Look at the advertising. It says make contact with UFOs and aliens by chemically changing your carbon vibration. I have no idea what this means. Sounds like pseudoscience, but I very much believe that those mushrooms will give you the perception of making contact with UFOs and aliens. Okay? These are not good for you, and they are still kind of expensive, especially if you get addicted, and it's not legal for you to be using these in many parts of the country, and so I do not recommend going this route, all right? So when it comes to augmented reality, what we're going to do is we're going to change your visual signal. And humanity is very, very good at this particular thing. Okay? Humans have been dealing with visual data for a long time, and we've been capturing visual data for a very long time. Photographs are a very old medium. And we have gotten very good at capturing, real-time, high frame rate, high fidelity, 4K, 8K visual data. We have the devices that can do this. And so cameras are the way that we can make this real, okay? If you have taken EECS 388, or if you know much about computer security, you may have heard of the famous man-in-the-middle attack. This is where you tell your web browser to reach out to a certain website, but actually something in the middle, okay? Something within your network, your Wi-Fi access point, something between your computer and the server that actually hosts that website is going to fake it. It's going to man-in-the-middle you. It's going to return to you a fake version of the website, which then steals your password after it convinces you to log in. It's a very dangerous attack, phishing attack. It's a man-in-the-middle attack. Well, what we're going to do is we're going to man-in-the-middle your senses, okay? We are going to take this visual data, all right? We're going to take this all these photons actually bouncing around in real life. We're going to capture them before they can get to your eyes. And we're going to transform that data, and then using a display, we're going to change that data and feed it to your eyes to add a whale. And the sensation when this works well is that there's now a whale here, right? This is a very, very promising route to take because this right here is something we're extremely good at. How do you collect image data? You use cameras. We have incredibly high quality sensors for this kind of thing. And a reminder, if you look at how VR headsets work, we basically started putting cameras all along the outside of the headset to figure out how you're moving through space. This also allowed a lot of our VR headsets, especially our modern ones, like the Apple Vision Pro or the Meta Quest, to give you this pass-through augmented reality mode, where you have the headset on, but you can still see all around you easily and not run into people. Okay? These cameras on the outside of our inside-out tracking VR devices, they used to be only grayscale because that's really all you need to understand the motion of an object through 3D space. But if you were to upgrade those cameras to something higher def, to full color, then you could use that data, okay, to give you an AR mode. This is the commercial for the Meta Quest Pro, which was really funny. It was actually a device that launched during, I think, our first ever debut semester of EECS 440. And a few semesters later, the visualization studio decided to purchase them and upgrade to Meta Quest Pro on all their devices in this room. So super cool. But having these expensive, high-quality color cameras on the outside of the device means that you can do a lot of very cool stuff. Like you can paint while you're in the device and you're looking at a real human being, and you can paint a digital painting and stuff like that. Okay? So modern AR devices, including the HoloLens 2, the Magic Leap 2, Spectacles 2 from Snap, they all have a ton of cameras on the outside of the device. And, you know, no surprise there, right? Our phones, often, you know, you choose which of these big, fancy, expensive smartphone devices to purchase based not just on the screen or the apps, but on that camera, right? Which smartphone has the best camera? Which one has the best sensors? Which one has the best processing in software once you've taken the photo? And so it's just wild. When you look at the back of an iPhone, you see this. Do you know, right? You know that these three big ones are cameras. Do you know what the top sensor is? This top, you know, right corner yellow sensor. Do you know what that is? Anyone? Okay. This is the flash sensor. So this can, I think, detect that you're in a low lighting situation, and it can generate a light flash to try and get you a better photo in the darkness. Now that's really cool, but what about that tiny sensor down there? Any idea? That sensor down there is somewhat new. It's a somewhat new invention. Well, not a new invention, but it's a fairly new feature to be adding to phones. It is, actually, I think I'm going to show you what that is soon. I'm not going to tell you what it is just yet, okay? But it is really cool. Interestingly, have you ever heard of Sony? Sony Corporation, right? Sony is famous, probably most famous for its PlayStation division, its video game division. But another big successful crown jewel of Sony is its camera sensor division. Apparently, most of the mobile phones, smartphones today, especially the high-end ones, will use sensors, camera sensors that were produced by Sony. And so Sony is a big company, but there are two really well-performing divisions, are the PlayStation division and the camera sensor division, which is kind of cool, isn't it? So we have this part of the equation, the AR equation, that humans are really good at, sensors, okay? We have this middle part of the equation, which is kind of where we aren't very good yet, all right? We are pretty bad at this, actually. This part in the middle is once we have that crisp, clear, high-def, high-res camera data, how do we make sense of it? Okay, this is the software situation. The challenge is this. Can you tell me what the following is? Can you tell me what this is? How would you describe this as a human? How would you?
A living room?
It's a living room, right? It's a living room. You see a couch, you see a rug, you see a brick wall, you see a window, okay? You can look at all of this and determine that it is a cozy indoor living room. But that's what a human sees, okay? Because a human can look at these things and say, hey, it's a living space. It's got a couch, a books, a rug. All these things are kind of in relation to each other. They're nearby. It looks like a living space. The big problem for us in augmented reality is that a human can make this distinction, but software often cannot, okay? A computer program that you write is going to load this image into RAM, and it's only going to see a bunch of pixels, okay? That's it. Beep boop. It's a 461 by 326 grid of 3 float tuples, RGB, red, green, blue. That's it. By default, without any hard work, this is the only thing the software knows about this image. It couldn't tell you what's in the image, okay? It just couldn't tell you. It has no idea what these things are, all right? This is a more accurate representation of what the software sees when it opens up this image. And I'm guessing I could show you this image to a human, and 100 out of 100 humans would have no idea what on earth this actually is, okay? So this is a very, very big problem, because in order to actually reason about and do things with this space, we have to look at this 2D image, which is the data coming through our camera sensors, and we have to actually know where the lights are. We have to know what objects are here. We have to know where the walls are, so that in our world, our digital fake AR object can bounce against the wall, okay, in the right place. So by default, the computer has no higher level understanding of what these pixels actually are or what they mean, or whether they're part of an edge or a surface or whatever. So one of the huge challenges in computer vision and augmented reality, if you go to a grad school, you might be working on this, is how do we help software understand a 3D world from a 2D chunk of data? And that's very hard, but it can be done. So look at this, all right? You can see right here that building a 3-dimensional mesh, a rendering mesh, but also a collision mesh from 2D data is a very, very important topic in computer graphics and AR and computer vision. And you can see here that existing technology is getting better at it. But actually, right, this is a research problem, an ongoing research problem called spatial mapping. And if you look at the mesh that's being built here, you can see some problems, okay? This is good, but not great. What happens if I were to have a game where I want to roll my ball underneath the couch? I've got a little ball, a little Unity sphere with a rigid body and a sphere collider on it. And I want to roll that ball underneath the couch. What's going to happen to my ball? What's going to happen? Go ahead. Yep.
It's going to collide with the mesh.
Yeah. My ball is going to kind of roll toward the couch. And then as soon as it starts to go under the couch, it's going to hit this mesh that's been built. In other words, this mesh right here is not very realistic. It's not very high fidelity. It is a very erroneous mesh. It kind of gets the general shape of the couch, but not too much more than that, all right? And so it's really not very good. So understanding the space, in other words, is our mission. You've got a 2D image. How does the software come to understand that space more precisely and better? If you look at this image right here, okay, this is not just about copying and pasting a whale on top of this image. It's going to look terrible if you do that kind of thing, all right? So we need to do some work. We can create a much more realistic image, final image, if we understand this space that we're putting the whale into. Because if this is a very dark space, then we need to shade and put shadows onto our whale. If this is a very well-lit space, which it is, then we need to make sure the whale is lit from certain angles. One thing you might want to understand about this space is, where are the walls? Where are the collisions going to happen in this space? Because the software has to decide where the whale should spawn. We can't spawn the whale in the middle of the wall or in the crowd. That would look terrible, okay? So we can do edge detection to figure out where the walls and flat planes of this space really are. We can also do light source detection. So we can look at a bunch of the pixels around the entire image, and we can kind of work backward to figure out where the light sources are. That's important because we need to know where the light sources are in the 3D version of this scene so that we can light our whale appropriately. Otherwise, the whale is going to look like it's not part of the scene. It's going to pop from the scene in a very bad way, okay? Another thing is object recognition. We really want to know that we're in a gym. Why? Because we might want to select some gym ambient music to play in the background. Or we might want to know that there are humans over on the right side of our shot. So the whale should start on the left hand of the area and should finish the performance on the right side, right in front of the humans. Imagine if it did the opposite. It would be really lame, right? It would be like in the corner showing off. That's not where the humans are. So we need to understand where the humans are, where the lights are, and where the collision volumes of this space is. And once we do that, we can finally create a convincing image, a convincing AR image. Image segmentation and object recognition. EECS 442 is going to actually have you implementing and studying some of the algorithms, the research-grade algorithms that can start to solve these problems, okay? Bring all of these together and you actually have an impressive effect of a whale animating exactly how you would want it, okay? Lit well, looks good. Of course, this is all fake. If Magic Leap was actually capable of doing this on the device in real time, then they would be a multi-billion-dollar company today. But I think today Magic Leap has almost no value whatsoever. In fact, I think they might have been sold. Let's go Magic Leap stock price. Oh, it's a private company. Okay. So yeah, not that valuable, I guess. Well, there you go. Okay. A quick note, yes, a reminder, this footage was totally fake. These problems haven't been solved to this level of quality yet. So spatial mapping is the problem of you've got a 2D image, extract a 3D mesh from it. Now, I asked you a bit earlier, what is this mystery sensor in the bottom right corner of your iPhone or smartphone camera system? What is it? Anyone know? It's something that's going to help. It's going to help us figure out 3D collision geometry. It is what we call LiDAR. It's a LiDAR sensor. It's the same kind of thing we see at the top of our automotive vehicles, our autonomous vehicles. How does it work? What does it do? Well, here's a really good shot that kind of shows you what it does. All right? Look at this. We can watch this video right here. I'll zoom in for you. And this is a technology that you have in your phone if you want to use it. And as we kind of go around this object, we can see that we are sending out this LiDAR scan. And we can actually do some very simple photogrammetry, which you will actually be required to do when you take the EECS 298 course next semester, the 3D Tech Art and Animation course. We'll teach you how to do all of this, and at a higher level of quality than what you see here. But that LiDAR sensor is going to go out, bump into the physical world, and it's going to help your software understand that 3D mesh. This, as you can imagine, is pretty useful for many things, not just scanning objects and bringing them into a game, but also for things like helping you avoid collisions. So you often see that many of our autonomous vehicles have LiDAR sensors all around the entire vehicle. This is May Mobility in downtown Ann Arbor, and they have quite a few LiDAR sensors. The way that it works, basically, is that you are directing this laser. You're directing this laser around the environment, usually in a 360-degree circle and usually very quickly. And you're actually detecting how quickly that LiDAR gets reflected off the object and returns to the sensor. And what happens is this. This is the data set that you get. You can tell that there's something right here. You don't know necessarily what it is, and you don't see the backside of the object. But that is a way that you can get concrete data about where physical things are in your vision. And that's extremely, extremely powerful data, okay? However, if you look at Tesla autonomous vehicles, they're not entirely autonomous, but if you look at the Tesla vehicle, can you point me to the LiDAR sensor? Did they just hide the LiDAR sensor really well on the Tesla? Okay. Tesla is a high-performance, like luxury vehicle. They do not want to uglify their vehicles by adding these ugly, chunky sensors everywhere. So what did they do? Yes?
Is it in the Tesla logo?
No. So Tesla vehicles don't use LiDAR. You know why? You know why they don't use LiDAR? Okay, point to me on your body where your LiDAR sensor is, where you send the lasers out. That's not a laser. It's just a receptor for photons, your eyes. Point me to where your LiDAR sensor is. You don't have one. Human beings have they have two camera sensors, okay? And like we talked about with VR, we can use stereoscopy. The fact that we have two different sources of data, slightly far apart, and we can use that to judge depth. In fact, you can even close your eye. You can only have one camera sensor and you can still judge depth. There are a lot of people that only have one functional eye, and they still don't run into things, okay? They don't just go bonking into everything all day. And so here's the question. Can we detect objects and collisions just from image data alone? And the answer is yes. Humans can absolutely do it. But the real hard question is, can we get software to a point where software can also do it? And the question is a bit up in the air, okay? When we come back next lecture, I'm going to show you some really cool data on how Tesla manages to detect things using only computer vision and build that 3D mesh using no LiDAR at all. But what you're going to find is that LiDAR is a very useful thing for preventing the worst case scenarios. Because in the same way that you can't drive effectively during a blizzard, Tesla can't drive effectively during a blizzard. But Google's Waymo service actually can, because it can detect things, even in a blizzard. It's crazy. Okay? All right, everyone. Thank you for joining us. I hope you enjoyed the lecture. And I wish you good luck. I wish you good luck, getting back into the spirit and, getting into this P2 alpha. Try and knock it out. It is a difficult assignment, not going to lie. So don't leave it to the last moment. But remember, if you don't get everything finished, you still have that P2 gold period to kind of finish up any tasks that you just have a rough draft for. Okay? So get all your P2 tasks done at a rough draft level. That should get you all the points for P2 Alpha. Okay? All right, everyone. We'll see you next time. Take care. Okay, everyone watching online, see you later. Bye-bye.